Today's class I am going to discuss about how to write the Verilog HTML code for 4-bit multiplier using EDA playground. So in this EDA playground we have two blocks. So first block, here I am writing the design code. Here I am writing the test bench Verilog HTML code. So we will discuss one by one. Let me write first design code for 4-bit multiplier. First I write module followed by module name. Module name is multiplier. Then I declare the input variables and output variable for multiplier. In this program I am taking two input variables A and B. It consists of 4-bit values. Let me assign the first input 3 down to 0 A. Then another input 3 down to 0 B. So B is the another input. Then now I declare the output variable output. So here output variable is 8-bit variable 7 down to 0 P. So P represent product term. So these two input variable consist of 4-bit value. After multiplying these two variable, we will get the 8-bit product term. So after declaration of input and output variables, then the next statement is always at A or B. If any changes occur in A or B, the output will give. Then begin. The product P equal to A multiplication B. Then end module. So this is the design code. Now come to the test bench Verilog HTML code. So first I write module followed by module name multiplier TB. So multiplier TB, that's a module name. Then declaration of input and output variable. So here input is A and B. This input variable is declared as rich and output variable declared as wire. So rich 3 down to 0 A comma B. So input variable declared as rich in test bench Verilog HTML code. Output variable declared as wire 7 down to 0 P. So after declaration of input and output variable, then declaration of instantiations. So here whatever name given in the design code, you just copy and paste. Then DUT design under test, declaration of instantiation variables dot A within bracket A comma dot B within bracket B comma dot P within bracket P. So this is the instantiation declaration. Then initial begin. If I need to show the waveform, means I am introducing the two statement $dump file test.vcd. Then next statement is $dump was 1. So these two statement help to show the waveform. So timing waveform for this multiplier. Then next I initialize the A and B value. Now A equal to 4 tick B 0 0 0. Initially let me assign the A variable is 4 tick B 0 0 0 0. B value also 4 tick B 0 0 0 0. Initially both the values are set to be 0. So after 10 nanosecond, so after 10 time cycle, now A value is changed from 0 to some other value. Let me assume A value 4 tick B 0 0 0 1. B value 4 tick B 0 0 1 0. Then I just copy this statement. Again I paste twice. So after 10 nanosecond, now A value change from 1 to 2 or 3. So here let me assume A value is 3, B value also 3. After 10 nanosecond, A value 4, A value 4, B value 10. Then after 10 nanosecond, display the result using the statement $display double quote A equal to %h. Here display the value in the form of hexadecimal. B equal to %h. Then P equal to %h. A comma B comma P. After 10 time cycle, finish the program, $finish. Then end module. So this is the test bench Verilog HDL code for 4-bit multiplier. So now I choose the tools and simulator. So here let me take Aldec Rivera Pro 2023.04. Then I press open EP wave after run the program. So let me save the program, the name multiplier. Just I click save. So after save the program, I just run the code. It will take few seconds to save the program. Just wait few seconds. So after save the program, so now I run the program. It will take few seconds to run the program. So now there is no error. We will get the result. This is the result. So here I am using the display statement A, B and P. So A and B is the input variable, P is the product term, output variable. So finally I give the A value is 4, B value is 10, 4 into 10, 40. So here the result shows A equal to 4, B equal to A. So A represents hexadecimal value, 10 equivalent hexadecimal value is A. The final answer product term P equal to 28. So this 28 represent 40 equivalent hexadecimal value. Now I show the waveform. So here initially I assign both A and B values are set to be 0 0. So the result is 0. The product term also 0. Then after 10 time cycle, now A value change from 0 to 1, B value change from 0 to 2. 1 into 2, the result is 2. After 10 time cycle, now the time cycle is 20. Here A value is 3, B value is 3. 3 into 3, 9. After 10 time cycle, the A value change from 3 to 4, B value change from 3 to A represent 10, 1 0 1 0. Just you multiply these two variable, finally you get the product term 28. This 28 represent hexadecimal value for 40. So this is the final result of 4-bit multiplier. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make lot of videos. Thanks for watching my channel. Thank you.